So we've demonstrated that this density parameter is really powerful as a predictor of whether something will sink or float. And density is equal to weight divided by volume. But what does this mean for sizing a boat? Well, here I have two cardboard boats made out of cartons, so they're waterproof. The container on the right has twice the weight as the one on the left. So how do you think it's going to float in the water? Do you think this is going to float higher or lower than the lighter weight boat? Well, let's check it out. Now here's my lighter weight boat, and it's floating at about roughly the top of the lower tape line. Where do you think my heavier boat is going to float? Let's test it. Whoa, look at that. Water is acting a little bit like a spring there, and it's taking a little bit of time to settle out. But it's floating at about the top of the second tape line. So let's think about our density equation. So density equals weight divided by volume. If I switch it around, I can solve for volume is equal to weight times density. So keeping density the same, if I double the weight, I double the volume. And that's pretty much what I'm seeing with my boats here. Twice the weight, it's taking twice the volume to displace the water to support the boat. Okay, does that make sense? What is it about this property of water that it's pushing up with a force equal to the weight of the boat? Okay, so this is the really tricky part. Let's step back a minute. What's the difference between solids, liquids, and gases? And what is so cool about water that it's able to know just exactly how heavy each boat is and how much water it needs to displace to support that boat? Well, a solid, like this block of wood, what do you notice? It's got a fixed shape and a fixed volume. So the size is constant. I can't just change it by pushing on it. Now, you could argue that I could take this bit of Play-Doh and I could push on it and change the shape, but actually the volume's not going to change. This lump of Play-Doh is the same size. I can roll it around, make it a different shape, but the volume's the same. And if I just sit it on the table and don't push on it, it holds its shape. So that's a property of a solid. Constant shape and a fixed volume. Water, not so much. So here I have a container of water. And you can see it's taken the shape of this container. Now I can pour it into a different container and it takes the shape of that container. So I can pour it back again and I haven't lost anything. So water has a constant volume, but if I put my hand in the tank, it just gets out of the way. I can't really press on it. So water is a liquid that has a constant volume, but no fixed shape. It takes the size of the container. Water and gases are both fluids, so they don't have a fixed shape. But do you know the difference between a gas and a liquid? A gas expands to fill the size of its container. So a gas doesn't have a constant volume. But it's this property of water that has a constant volume that makes it so cool for a boat sizing calculation, because that means I can figure out how much weight I need to support. And once I know the weight that I want to support with my boat, and I know, or I can look up the density of water, then I can calculate how much volume my boat needs to have in order to support that weight. So both of these boats are in equilibrium. They're not moving. So the weight of the boat pushing down is equal to the buoyant force of the water pushing up. And we know from our density equation that weight equals volume times density, or I can rearrange that and say volume equals weight times density. And what that means is twice the weight means I have to displace twice the volume of water to balance out. So the water line of these boats is determined by the weight and the volume of water displaced. So volume equals weight times density, in this case density of water. So twice the weight is twice the volume. And now I have a design decision. I can decide what weight my boat needs to carry and solve for the minimum volume. Now, volume, how do I calculate that? Well, that's for the next video. So we have lots of design options now. And that's the fun that engineers have, is in designing things for different uses. So let's take a look at what some of those design options might be.